All right, the last topic that we'll look at here in Unit 3, as far as giving you a preview for, would be writing equations in slope-intercept form. In your 143 class, you'll also have a section on exponential growth and decay, but you have a formula associated with that one. I feel like it's fairly straightforward, but always reach out if you need more help. But I've really tried to focus my previews here on the harder material associated with the course. All right, so here on the front page, it says that you have $500 in your savings account and commit to a savings plan of $100 per month. They want us to set up an equation and use it to find out how much money will be in the savings account after 1 year. So we've got to think about our independent and dependent variables. So for our independent and dependent variables here, let's think about what's happening here. You've got the amount of money in your account. So we've got the amount of money in our savings account, and then we've also got the amount of months that we're putting into that account. So hopefully you would agree here that the amount in your account, the amount in the savings account would be dependent upon the number of months that you've been saving. So, and remember that for our, independent and dependent variable, remember this is your x and this is your y. So that we go to write our equation, y equals mx plus b. M is your slope, and so that's the amount. M is how you move, and so that's how, what it's changing by each month. And so here we know that we're changing by how much you add in each month, which is $100. So we'll put 100x plus B. Remember, B is your y-intercept, or where you started your savings account at, and they told us here that we started it at $500. Okay, that would be our linear equation here. So sometimes you're going to have problems that are written out for you, and the context of the problem will tell you where you begin and how much you're increasing or decreasing by, and you'll be able to write your equation outright. We'll step it up from there because they're not always that straightforward here in a few moments. Now the solution below wants us to figure out, well, we're using this equation, we want to figure out, well, then how much is going to be in the savings account after 1 year. So 1 year is equivalent to 12 months. So in place of our months, that's our x value. So in place of our x value, you're going to put in 12. So y equals 100 times 12 plus 500. Put that all in your calculator at one time. 1,200 plus 500, that would put us at 1,700. So at the end of the year, you'd have $1,700 in your savings account. Okay. I encourage you to pause now, try example 2, check yourself by the solution key. I'm going to do example 3 with you. Okay, so you can see another one. In example 3, Paul started a diet 2 months ago to help him make weight for his next boxing match. Paul's starting weight was 175 pounds, and he wants to lose 1.5 pounds per week. They want us to set up an equation and use it to find out how many weeks it's going to take Paul to reach 166 pounds. So your independent and dependent variables again here, well, we're trying to figure out, we've got to figure out his weight, and he's trying to lose it per week. So his weight is going to be dependent upon the number of weeks that he's been losing weight, that I've spent I'll just say I've spent training, really focusing on trying to lose the weight. Okay, so now my equation, y equals my slope this time, remember that's how much it's changing by each unit of time. Here we are losing 1.5 pounds per week, so my 1.5 is going to be negative, plus his starting weight, right? That would be your y-intercept, and he started at 175, so that would be my equation. Remember that independent is your x, dependent is your y. They want to know how many weeks it's going to take Paulo to reach the 166 pounds. So that 166 pounds, that's a weight. A weight goes in for your y value. because we've identified our y value here as weight. So 166, and for the weight, equals negative 1.5 x plus 175, and we'll solve for x. So we subtract 175. We want to get closer and closer to getting that x all by itself. Negative 1.5 x equals negative 9. Divide both sides by negative 1.5. Divide there, you should get 6. So you're talking about 6 weeks. It would take him 6 weeks to achieve his goal weight of 166 pounds. Okay, let's flip it on over. Top of the next page, we talk about other ways to write our equations in slope-intercept form. One way is that you may be given a graph, and by being given a graph, you can a lot of times crank out your equation fairly easily by the information that they've given you. So remember that from a graph, we can do a slope triangle and calculate our slope. So I just chose my x and y intercepts because those are definitely perfect points. So I would rise. If I start from this bottommost point, I would rise until I get in line with that other point. So I rose 6 units. So my slope is rise over run. I just rose a positive 6 units. And then I'm running to the right. But notice the scale here, you're running by 2. So 2, 4, 6, 8 units. And you went to the right, so that's positive. 6/8 can be reduced, divided both by 2. And you have 3/4. So you've got a slope of 3/4. The y-intercept, we don't have to do any work. We can see, oh, it's crossing the y-axis here at -6. Once you have a slope and a y-intercept, you can write your equation. Y equals 3/4 x minus 6. Final answer. Okay. I encourage you to do letter B there so that you can kind of mimic exactly what I was just doing there. Pick 2 points that you know exactly what they are. Calculate your rise and your run. The y-intercept is identified for you over there as well, and then you've got your equation, okay? All right, let's step it up a notch. Suppose we don't have a graph, we don't have a context. Steps for finding the equation when your 2 points are given. You plug those 2 points in their slope formula, right? So your slope formula, remember, is your y2 minus y1 over x2 minus x1. Remember that formula from the last video? Remember, you've got to know that formula. Using the formula y equals mx plus b, substitute in these values. Solve for your b, and then write your equation in slope-intercept form. So let's do example 5 here from top to bottom. So in example 5, I'll try to do this in steps here so that you can see that. So the first thing that you do is calculate the slope. So m equals, I'm going to come over here and label this x1, y1, x2, y2. So m equals y2, which is 3, minus 5, over y2 is 1. Oh, excuse me. I think I just goofed. No, I didn't. I'm sorry. I did goof the back of that. Okay, let me start it. Y2, 3 minus 5. On the bottom, x2, which is 1, minus negative 3. All right, so now up top, if I clean that up, 3 minus 5 gives me negative 2. On the bottom, 2 negatives become positive, so I have 4, and that can be reduced to negative 1/2. Okay, so that's step 1. Step 2 says use your slope formula, y equals mx plus b, and plug in everything that you know. So at this point, you know the slope, and then you have an ordered pair that you could use for x and y. You choose one of these points, okay? So you either choose the first order pair and go with it, or you choose the second order pair and go with it. But you can't cherry pick and say, I want this y and I want that x, okay? That's not legal. You have to pick a point and go with it. So what I'm going to do here is I'm going to box in what I'm going to use. I've got to use the slope. We just calculated that. I've got to use that. I'm going to choose to use the second order pair because it has all positive values. You don't have to, but I feel like, you know, you'd be less apt to make a mistake with your signs if you use positive values. So now in place I'm going to, in place of everything that I know, I'm going to input that, substitute. So in place of y, okay, my y value is 3. In place of m, I just found that, that's negative 1/2. In place of x, x is 1. plus b is the y-intercept. I don't know what that is, so I've got to, that's what I'm trying to solve for. Now from here, let's clean up a little bit. Negative 1/2 times 1 is still negative 1/2. And then lastly, to get that b all by itself, add 1/2. So b equals, you could write this as 3.5. I think I'm going to write it as a fraction here as 7/2. But I'll write here that you could also use 3.5. You just typically don't mix fractions and decimals. And since I had written the slope here as 1/2 instead of 0.5, then I'm going to use the y-intercept here as 7/2. But your last step then is just to write your equation in slope-intercept form. Because at this point, you have m and you have b. So y equals mx plus b, your linear equation, just substitute in for m and b. So m is negative 1/2 x plus b plus 7/2. Like I said, you could also do this. Y equals negative 0.5 x plus 3.5. That would be legal. You just typically don't write 1/2 and then 3.5 over here. You don't mix the fractions and the decimals. That's what I meant. So either keep it all fraction or keep it all the decimal. Okay. Don't do any rounding though. So if you have to do rounding, then you need to use the fraction format and use your calculator. I encourage you to stop now and try example 6 and make sure you're good with that 3-step process that I was just showing you there. Okay. All right. Let's move it on over then to the next page. In example 7, it's very similar to what we've been doing. They say find the equation of a line passing through. This time they just give you 1 point and a slope. So essentially, they've just taken out a step from what we just did. Because if you notice, I had a 3-step process. The very first thing I had you calculate was the slope. Well, step 1's done. The slope's already been calculated. So all that we need to do then is that we need to find b. So the first thing we're going to do here is solve for b. So you're going to have y equals mx plus b. And you've got an x and a y, and you've got your m here. So you're plugging in for m, x, and y and solving for b. So in place of y, I'll put in my 3. M is going to be negative 4. X is 2. Don't know what b is. We're solving for that. Clean up. Negative 4 times 2, of course, is negative 8. Get that b all by itself, so add 8 to both sides. So b equals 11. So final answer then, I've got a slope and I've got a y-intercept, so y equals negative 4x plus 11. Final answer. Okay, so just recognize that if you already have the slope, you can skip that first step that we were doing before. All right, let's look at example 8. We step it up a notch here. We'll take this one from top to bottom. So here they tell us that a car's value decreases as the car gets older, of course. For tax purposes, the value of the car is calculated by using a linear relationship. A particular car is worth $21,000 when it's a year old and $8,000 when it's 5 years old. So part A says find the equation of a line that gives the value of the car in dollars when it's t years old. So we've got two variables here. We've got the value of the car and its age. So what we can say here is that we're trying to figure out, okay, which is x and which is y. The value of this car, would be dependent upon the age of the car. So it tells us, okay, all right, so in place of y will always be my value, in place of x will always be the age of the car. Now, let's think about, because now that we have that information, with the last sentence up here, that can now be converted into two ordered pairs, right? Because our ordered pairs are always going to be x comma y. They're always going to be an age, comma, a value. So for us, then, one of those ordered pairs is, we know that, well, when it's 1 year old, it has a value of 21,000. When it's 5 years old, it has a value of 8,000, right? I've got an age, comma, value, age, comma, value. Now that you have two ordered pairs, you can use those two ordered pairs in your slope formula to find the slope itself. So do that, right? This is x1, y1, x2, y2. So to find my slope, I'm going to have 8,000 minus 21,000 over 5 minus 1. That would be a negative 13,000 up top. Then divide by 4, and I have a negative 3250. Okay. So you've got your slope. I'm just going to put a little m above that and box it in. I know what my slope is. Then I need to figure out what my y-intercept is. So I go to y equals mx plus b. Plug in everything that I know. You can choose the first ordered pair or the second ordered pair. I'm just going to choose the first one, but if you want to try the second one, everybody's going to get the same answer. It does not matter. So if I use the first ordered pair, then I'm going to, in place of y, I'll be putting in 21,000. M is the negative 3250 that we just found. You multiply that times x, and the x then is going to be 1 for b, and then plus b. Clean that up. Negative 3250 times 1 is still negative 3250 plus b. Then to get b all by itself, I add 3250. Cancels out, and so b equals 24,250. So now you have an m and a b. Last step, get your equation. Final answer, to be sure you don't forget to do this, y equals negative 3250x plus 24,250. That's our final answer. Kind of see if I can fit it all on there so it looks better. Y equals negative 32. Part B wants us to interpret the slope. Let me box that in. That is our final answer. That is our equation now that we'll be using for the rest of to answer the rest of these problems. Part B wants us to interpret the slope. Slope remembers the number in front of x. So here you have negative 3250 over 1. Remember, slope is the change in y over the change in x. We come back up here and we recognize, okay, my y is the value of the car. So up here, this is the value. On the bottom, that's your x, so this is the age of the car. So then what we're seeing here then is that every year the value of the car decreases by $3,250. So every year the value, oh goodness, I promise I don't have this bad of handwriting. Every year the value of the car decreases. Goodness, what has happened to it? By $3,250. All right, so this will get a little bit better here in terms of my pen. And part C wants us to find and interpret the x-intercept for this equation. So your x-intercept, remember, is always of the form, remember, x-intercepts are always some number, comma, 0. So you're plugging into your equation, you're plugging 0 in for y and solving for x. So for our equation, I'll remind you, was y equals negative 3250x plus 24,250. So I plug 0 in for y, and I'm solving for x. It's always the case. Anytime you're trying to solve for an x-intercept, you're always plugging 0 in for y and solving for x. I subtract that 24,250. So negative 24,250 equals a negative 3250x. Divide by negative 3250. So x equals 7.5. So if I were writing my ordered pair, then I have 7.5, comma 0. That's my x-intercept. Now remember that this represents a value, represents a year and a value. So we can say here, or the meaning here is that in 7.5 years, the car will have no value. Okay. Part D wants us to find and interpret the y-intercept. The nice thing about the y-intercept, once you have an equation in slope-intercept form, you've done the hard work. Because we know, oh, this is our equation, y equals negative 3250x plus 24,250. Remember, we know, okay, well, this number's sitting out here, that's my y-intercept. So my y-intercept here then is 0, 24,250. That's my y-intercept. This is your year. This is the value of your car. So essentially, at time 0, or brand new, this car was worth $24,250. So I'll word it like that. Brand new, the car was worth $24,250. Okay. Part E wants us to find the value of the car when it's 3 years old. You're putting, there's a time. Time is always your x, so in place of x, you're plugging in 3. So negative 3250 times 3 plus 24,250. You can put that in your calculator all at one time, and you should arrive at 14,500. That would be the value of the car. And then lastly, in part F, it wants to know, well, when is this car going to be worth 5,000? It's asking for a when. It's asking for a time. That means we're going to be solving for x. They're giving us a value. Values go in for y. So 5,000 equals negative 3250x plus the 24,250. We want to solve for x. To get closer and closer to getting this term all by itself, we're going to subtract the 24,250. Cancels out. So we have negative 3250x. 5,000 minus that 24,250 will give you a negative 19,250. Then divide by the negative 3250. Cancels out over here, just leaves us with x. Doesn't come out, perfectly nice, but we'll say here's about 5.9. So we'll just go ahead and round that up and say, okay, it does tell you this. It does here. It tells us to round up to the nearest whole number. So approximately then 6 years. It's going to take it 6 years to get down to $5,000. Okay. All right. So the next 3 problems in this set of notes have to do with you creating a scatter plot, and then after you've created that scatter plot, I tell you to pick certain points and create a linear model. The first one here, or example 9, is a little easier than the next 2. So for that reason, I'm going to skip example 9, let you come back and try that one on your own. And what I'd like to do is to do example 10 with you. Okay, so let's look at that one. Like I said, all 3 of these last problems are the exact same type. They're just different because this is some of the harder material, so I want to give you a lot of practice with it. Here in example 10, the table shows the number of individual tax returns in millions filed in the U.S. in the years from 2000 to 2009, and we're going to let x equal the number of years since 2000. They want us to graph this data on the scatter plot and then put in what's referred to as an eyeball line of best fit. All right, so first thing we want to highlight here is they're telling us to let x equal the number of years since 2000. So what that means then is along the x-axis, I'm not going to be putting years, I'm going to be putting years since 2000. And on the y-axis then that has to be your tax returns. So this would be the number of tax returns. And of course, these would be in millions. All right, now let's focus a little bit heavier on the fact that this is number of years since 2000. Well, 2000 then would be 0 years since 2000. 2001, okay, that'd be 1 year after. 2002, 2003. This will be 3 years after. 4, 5, 6. You have to be careful. I mean, sometimes this one is counting in order, but sometimes they'll be a little bit more sporadic. Like it might jump from 2000 and then they have data for 2005, 2007, 2008, and then they go to 2012. So you have to be careful about that. But essentially here, all that I'm doing is subtracting 2000 from each of these values. This will be 7 years after, 2008, 9 years after. So just be sure you're mindful of that. You can see here that your data on the y-axis, so that means then I can label, don't get too far ahead of myself, that means now I can label my x-axis and just counting in 1, so 0 through 9. So I'll just go here 1, 2, 3. I'll just go ahead and finish it out and make it complete. 14, 15, okay. Come back up. You can notice here on your y-axis that your values are ranging from 125 to 139. So what I did is I started at 100 and then counted by fives. Okay, so I have, like here, this is 100 and then I counted by 5. So 105, 10, like so, okay. I do need a break here in my graph because this is representing 100 units and everything else is representing 5 units. I don't need it on the x-axis because this from here to here is 1 unit and everywhere else is also 1 unit. Now I'm going to plot each of these individual points. So I have 0, 125, for example. So let me put that one in. 0, 125 will be my first point. Then 1, 127. So about halfway in between there. 2, 129. 3, 130. 4, 130. 5, 131. 6, 132. 7, 135. 8, 138. And 9, 139. Okay. So you've done everything but what's referred to as your eyeball line of best fit. And an eyeball line of best fit is just trying to shoot through the middle of your data. And I'll show you some bad examples of a line of best fit. If you put a line, like for example, if I did that, I only went through 1 point. That is not a good eyeball line of best fit. Okay. Another bad line, let me put that point back. Did I do that right? 4, 130? Yes. Another bad line would be if I only went through those 2 points, for example. It is a straight line, it's passing through 2 points, but the majority of the data is below that line, okay? Like I said, you want to try to shoot through the middle of your data. So I'm a little nervous here of trying to do this freehand, but we'll see what happens. So 125 and then 127 were my points. All right, so what I'm trying to do here is to roughly, like I said, sort of hit through the middle as best I can. Let me make my line a little bit narrower. You would be able to, I can do it better on my paper than I can here, but we'll try. Trying to do something like that. That's not too bad. Okay, that I ended up here kind of passing through about roughly 3 points. I ended up with 3 points above my line and 4 points below. So I'm roughly going through the middle of my data. If you ended up with no data points above and 5 below, you're not quite going through the middle that way. Okay, so you want to try to, that's what we mean by an eyeball line of best fit. You're running straight through the middle of your data as best as possible. All right, let's scoot on down here then to part A. It says pick the first and 9th points to approximate our linear model. So the first and 9th points, your first point was the point 0, 125. And then the 9th point was the point 8, 138, excuse me, 8, 138. So what I did, I came up here and, here's the first point. And then 2, 3, 4, 5, 6, 7, 8. There's my 9th point. So 8, 138. Okay. All right. So now I've got 2 ordered pairs here. I can find my slope. Right. 138 minus 125 divided by 8 minus 0. And that's going to be 13 divided by 8. You can leave it as a fraction, but 13 divided by 8 in this case is a nice decimal, so I figure most people like to work with a nice decimal if they can, so I'm going to put 1.625. But if you want to work with the fraction, you certainly can. At this point, we typically, our next step is that we go and find the y-intercept. But here, if you go back and look, I told you that your line passed through these 2 points, and hopefully you recognize this ordered pair here is a y-intercept. So since that's the case, I get to use that point. If I had not chosen that point for you to go through, you would have to do that next step where you go and use your y equals mx plus b and solve for b. But since I told you that yours would go through that particular point, you get to use that y-intercept, okay? That can sometimes be confusing for folks, and I believe that you're going to see that play out on the next page. Yes, that the y-intercept is in the data, but the 2 points that I choose for you do not go through the y-intercept, so you can't use the y-intercept in the data. You've got to calculate the y-intercept, okay? So from here, I'm going to do, I can go ahead and write my equation, right? Because I have a slope, and I gave you the y-intercept. So y equals 1.625x plus 125. That will be the equation that we use throughout the problem. Part B wants us to interpret the slope. So we can interpret this. We can interpret it one of 2 ways. I'll show both ways. So if you keep it in the decimal format, then you have 1.625 over 1. Remember, slope is the change in y, so on the y-axis we're measuring the number of tax returns. And on the x-axis we're measuring the number of years since 2000. So in this format we could say that every year since 2000, every year since 2000, the number of tax returns increased by 1.625 million. Okay. Let me also do this in the fraction format. So if you chose the 13 over 8, it's still the number of tax returns, so this is still representing your tax returns up top, and this is still your years down here since 2000. This one is just going to be now every 8 years since 2000. Every 8 years since 2000, the number of tax returns increased by 13 million. You could write the word million behind it, or you can put all the zeros behind it if you like. Okay, so either one of those are perfectly legitimate to use. Okay, we'll move on down then to part C. It says use the model to predict the number of individual tax returns in 2011. And they're asking us to round to the nearest whole number. We can't just put 2011 into our formula, right? Because X up here represents the number of years since 2000. So we need to first figure out, well, what's our X going to be? So you would take 2011 minus 2000. Oh, okay, so X equals 11. So you're going to plug in 11 for X. So Y equals 1.625 times 11 plus 125. That should put you at 142.875. Round to the nearest whole number, so that 8 rounds you up to 143 million. Okay. Part D, you would be, it says to predict the number of individual tax returns in 2013. You'd be doing the same thing. It's just that this time you're going to let X equal, got to figure out the number of years since 2000. Okay, you're going to let X equal 13. So it's the same work there. You should arrive here at 146 million. Okay. Then in letter E, they want to know in what year will the number of tax returns be 200 million. So now, okay, well, they're telling us the number of tax returns is 200 million. You don't need to put in all those zeros because remember it's already in terms of millions. So you're just going to put in 200 for your y and solve for x. 1.625x plus 125. We'll subtract 125, trying to get closer and closer to getting that x all by itself. And cancels out, so 1.625x equals 75. Divide by 1.625, and so x equals 46. So remember, it's not, they're asking you when. It's 46 years after the year, because x represents the number of years since 2000. So since we're in reference to 2000, we're going to add 2000 to that. So we're talking about the year 2046. If this were the number of years since 1980, I'd be taking 46 plus 1980 here, for example. Okay. All right. On the last page, what I want to do on that page with you is just talk about the scatter plot again, part A and part B essentially. That's what I want to work with you, and then let you try the rest on your own. So here they're telling you this gives the number of immigrants in the U.S. as a percentage of the total population. Here they're telling us that let t equal 0 represent the number of years since 1970. So in our x column over here, 1970 then would be times 0. 1980, number of years since 1970, that's going to be 10 years later. 1990 would be 20 years later. 2000 would be 30 years later. And then be careful here, 2007 would be 37 years later. Okay. So that, then along the x-axis here, you're measuring the number of years since 1970. And then on the y-axis, we are measuring percent of population as immigrants. So on the x-axis here, I'll just choose to count by fives. So 5, 10. Should be enough. Along the y-axis, your data is ranging from 4.7 to 12.6. So I just chose to count by twos. Plot my data. So I have 0, 4.7, 10, 6.2, 20, 7.9, 30, 11.1, and 37. Okay, being here, 12.6. Probably there. I'm trying to shoot an eyeball line of best fit through this data. Like I said, you just kind of want to shoot through the middle as best you can. Not too bad there. Ended up with basically going through roughly about 3 of them, or fairly close. If you think of only getting through 1, then I'm fairly close to having 2 above and 2 below. Okay. Right, notice here in part B, it says find the equation of your linear model using your second and fourth points. So your second and fourth points would correspond to 10, 6.2, and 30, 11.1. I'll just go ahead and tell you, and this is what I meant by that last problem. The y-intercept is part of your data. However, I'm asking you to find a line that goes through these 2 points. So if it goes through these 2 points, it's not also going through that point, that 4.7 there. So you are going to have to not only find your slope here, y2 minus y1, but then you're also, after you find that slope, you're going to have to go to y equals mx plus b, choose one of these points, either one, and plug it in for x and y, and that M that you just found and solve for your B. Okay, that's the difference. In the last problem, the ordered pair, one of the ordered pairs that I chose for you was the y-intercept. In this one, neither one of these is the y-intercept, so you've got to do this second step over here. Okay, I've shown all my work online, but I wanted to explicitly show you what I meant by that here. Okay, if you have any questions or if you need me to work further, always shoot me an email and I can make you a quick video. Thanks a lot. Bye.